look at Pythagorean theorem today. You're probably wondering, why do I have to talk about Pythagorean theorem in algebra? But that's because it deals with square roots. So it is in this unit because of the square roots that we've been learning, and you have to know how to simplify a square root to be able to work these. You will do these a ton in geometry. So everything you're learning today, you will do a lot next year. So you got to make sure you really understand it. All right, so Pythagorean theorem is used when you have a right triangle and you are trying to find one of the sides of the triangle. Okay, you've got your two legs. So you've got a leg here, and you have a leg here. Okay, so you have your two legs, and then this third side, that is called your hypotenuse. Okay, the formula for the Pythagorean theorem is a squared plus b squared equals c squared. Okay, and your legs, those can be your A or your B. Now obviously y'all seen this before, so this isn't anything new, but let's say that's A, that's B, but your hypotenuse is always your C. So that's always C. It doesn't matter which leg you make A and B, but your hypotenuse has to be your C. So what we're going to do is we're just going to find the value of x. We're going to find the missing side of the right triangle. Okay, now first decide which one is your A, B, and C. Well, I know that the hypotenuse, this side right here, I know that that was my C. And then A and B doesn't matter from there. So I'm just going to label A, B, and C. And I'm going to plug this in. Now I need to see you plugging it in. I do not want you to do it in your head. If you turn your homework in with only answers, it's going to be wrong. I need to see it plugged in. So you've got 3 squared. I don't even want you saying that's 9 yet. I want you to write 3 squared plus 7 squared equals c squared. Now we're going to start to simplify this. So 3 squared is 9 plus 49 equals c squared. Now I can simplify this again. So 9 plus 49, that's 58. So I have 58 equals c squared. Now, how do we get rid of that squared on the c? We take the square root. So you got to take the square root of both sides. Now we get to where we have been this unit. Okay, we have the square root of 58, and we have to figure out, are there any perfect squares in 58? The good news is here that there is not. I do not want you to type this in your calculator as square root of 58 and tell me the answer is 7.61. I need you to simplify the radical. Now if it was multiple choice and the answers were in decimals, then you could just type that in your calculator, but I want you to simplify that. And here, that's already simplified, so c is equal to the square root of 58. And that's my missing side. Okay, example 2, find the value of x. All right, so we know that our hypotenuse here, that is our c side, and the other sides do not matter. Okay, so I'm going to plug this in. So I have 4 squared plus, now I need x minus 2 squared. So I'm going to put that in parentheses and square it, and then that's equal to c squared, which is x, so x squared. Now this one requires a little bit more work, okay? Obviously the 4 squared is easy, that's 16. Okay, but x minus 2, I need to square that. And there's not a way you can do that without writing x minus 2 times x minus 2. There is a way, we just shouldn't really talk about it because I think it's just more confusing. So you have to expand that into x minus 2 times x minus 2, and now it's going to need to be FOILed. Okay, so I still have that 16 plus. Now we have to FOIL this. So I have x times x is x squared. X times negative 2 is a minus 2x. The inside is minus 2x. And then negative 2 times negative 2 is a positive 4. All right, now we need to keep simplifying this. So I have 16 and I have a positive 4, so that's 20. I have x squared, so plus x squared. And then I have a negative 2x minus 2x, which is minus 4x, is equal to x squared. I still have to keep solving this. So I have an x squared on both sides of the equal sign, so I'm going to get those together. So I'm going to subtract x squared. Okay, so that leaves me with 20 minus 4x is equal to 0. I don't have anything over there anymore. So what I'm going to do is subtract this 20 and move it over. I'm just solving this for x. So I have negative 4x equals negative 20. Divide by negative 4. So after all that work, we find out that x is 5. Okay, if you wanted to check that, you could. Just come over to your triangle and write in 5 for the x's, and on b, the b side, 5 minus 2 is 3. We're going to figure out later that 3, 4, 5 is a triangle that you're going to remember. So there we go, there's our 3, 4, 5 triangle. Now, yes, this was a little bit more difficult. No, you're not going to have a lot like this, but you definitely need to know how to do it. All right, number 3, find the value of x. Okay, so I need to find this, which is going to end up being my hypotenuse, so that's my C. And I need to actually make a triangle here. So we need to figure out what each side is. Okay, well, we know the tall side is 8. Okay, now we know this little piece of the square is 5, which means this other piece of the triangle needs to be 6. All right, so it doesn't matter what your A and B are here, but your C has to be your x. So I've got 8 squared plus 6 squared equals x squared. So 8 squared is 64, 6 squared is 36, equals x squared. 64 plus 36 is 100, equals x squared. And how do you get the squared off? You take the square root. And what is the square root of 100? X would be 10. All right, example 4, find the value of x. All right, so notice this is very different because we have a square root in here. Okay, well this is showing us that this is a square because all sides are the same, which means if this leg is x, that means the other leg is also x. Okay, so we're going to plug this into Pythagorean theorem, and the 5 root 2 side is going to be my c. So I have x squared plus x squared equals 5 square root of 2 squared. That's going to be the tricky part. Okay, so I have x squared plus x squared. So I have 1x squared plus 1x squared. That means we have 2x squared. So do not touch the exponents there. Now I'm going to work this out to the side, the 5 root 2 squared part. So I have 5 square root of 2 times 5 square root of 2, because that's what it means to be squared. So now I'm going to work this out. So now you should know how to do this from what we did the other day. You've got 5 times 5 is 25. Then I have square root of 2 times square root of 2. Remember, any square root times itself ends up being the number underneath. So square root of 2 times square root of 2 is 2, and 25 times 2 is 50. So I end up with 2x squared equals 50. Now anytime you end up squaring a square root like we are here, you're going to end up with a whole number. So if you need to type this whole thing, that whole part in your calculator, then just do that. Okay, now I need to solve this. So I'm going to divide both sides by 2. So I have x squared equals 25. Take the square root of both sides, and the square root of 25 is 5. If you wanted to check that, you could. You just plug it back into the Pythagorean theorem, and it all has got to be equal. Okay, so now we're going to look at a couple more like wordy problems. So example 1, the legs of a right triangle are 3 and 4. What is the length of the hypotenuse? All right, so we've got this triangle. Make sure you draw pictures on these. And the legs are 3 and 4, and we're looking for the hypotenuse. So we're looking for C. So I'm going to plug this into Pythagorean theorem. So I have 3 squared plus 4 squared equals C squared. Make sure you have that written down. Now you can simplify it to 9 plus 16 equals C squared. Well, 9 plus 16 is 25 equals C squared. Now you take the square root. So that means that C is 5. Notice that's that 3, 4, 5 triangle again. You're going to see that actually quite a bit. Number 2, the leg and hypotenuse of a right triangle are 24 and 26. What is the length of the other leg? All right, here we go. So we've got this triangle. It's telling us that the leg and hypotenuse of a right triangle are 24 and 26. So a leg is 24 and the hypotenuse is 26. Make sure you get that in the right spot. And it's this other side that we are looking for. So I'm just going to call that B. So I have 24 squared plus B squared equals 26 squared. 24 squared is 576 plus B squared equals 26 squared is 676. Now we got to keep working this out. So I'm going to subtract 576 and move it over. So I have B squared equals 676 minus 576 is 100, which is a nice number. I'm going to take the square root of both sides, and the square root of 100 is 10. There we go. Okay, now we're going to do a couple word problems. So this says you're traveling from Valmont to Milesburg. You can avoid the city traffic by taking the L-shaped route shown. If you could travel straight through the city, how many miles could you save? Round your answer to the nearest mile. So this is actually telling us that we can have decimal answers because it's telling us to round. Okay, so it's wanting us to figure out what this root is right here. It's wanting us to find C. Okay, so we have to figure out what that C side is. All right, so I've got 13.5 squared plus 25.75 squared equals C squared. 13.5 squared is 182.25 plus 25.75 squared is 663.0, and I'm just going to round that to 0.06, and that's equal to C squared. So I'm going to do 663.06 plus 182.25, which is 845.31, is equal to C squared. And now I'm going to take the square root of both sides. So the square root of 845.31 is 29.07. All right, so that gets us the C side. But what is it asking? It's asking how many miles could you save? Well, if we went the route that they're showing on here, so the 25.75 plus the 13.5, so 25.75 plus 13.5, that would have taken 39.25 miles. So how much are we saving by going 29.07? So I'm going to subtract those. So we are saving about, it says to the nearest mile, so that would be about 10 miles when I subtract those. Okay, a fire truck parks beside a building such that the base of the ladder is 16 feet from the building. The fire truck extends its ladder 30 feet. How high is the top of the ladder above the ground? Okay, so we know that this is going to be a triangle because we're talking about Pythagorean theorem. So the fire truck parks beside a building such that the base of the ladder, so here's our ladder leaning up against the building right here. So the base of the ladder is 16 feet from the building, and here's the building over here. Okay, so it's 16 feet from the building. The fire truck extends its ladder 30 feet. Okay, well here's the ladder leaning up against the building, so that is 30 feet. How high is the top of the ladder above the ground? So we're trying to figure out how high that building is, basically. The hardest part of these is figuring out where your numbers need to go. So you really need to be careful, because from here, the Pythagorean theorem is easy. It's just figuring out where those numbers go. All right, so here we go. I've got x squared plus 16 squared equals 30 squared. So I have x squared plus 16 squared is 256. Equals 30 squared, which is 900. I'm going to subtract this 256 from both sides. When I do that, I get x squared is equal to 644. Now I'm going to check to make sure that's not a perfect square, and it's not. And I want to get this, we're going to get this both ways. We're going to get it as a simplified radical, and we're going to get it as a decimal, because it doesn't tell me how to do this. So if it was a decimal, it would be about 25.38. Now if I wanted to simplify this, I need to figure out if there are any perfect squares in 644. And I'm going to have to do that in my calculator because I just do not know. Okay, so I think this breaks down into 4 times 161. I don't think there's any perfect squares in 161. So I'm going to circle my perfect square. The square root of 4 is 2, so I'm going to bring that out, and I'm left with the square root of 161. And that's my answer. So there it is both ways, as a simplified radical and as a decimal. You need to know how to do both. Okay, what this slide is showing you, I kind of talked about this earlier, but there's something called a Pythagorean triple. This is a set of 3 non-zero whole numbers, a, b, and c, such that a squared plus b squared equals c squared. It's called a Pythagorean triple. These are numbers that are definite go-tos for a triangle, for a right triangle. So if I give you that the legs are 3 and 4, you can tell me the hypotenuse is 5. If I tell you my legs are 5 and 12, you can tell me the hypotenuse is 13, because you know the biggest side is your hypotenuse. So if you can have these triples memorized, you definitely do not have to memorize them this year. You can just do the Pythagorean theorem to figure out your third side. But if you know these triples, it will definitely save you some time, and it'll definitely help you next year. Okay, now these triples, you can also use their multiples. So if you look down here at the bottom, if you look at this 3, 4, and 5, if you multiply all those numbers by 2, you get 6, 8, 10. If you multiply all those numbers by 3, you get 9, 12, 15. If you multiply all those numbers by 10, you get 30, 40, 50. So these are multiples of that same triple. So if I gave you the sides 6 and 8, you could tell me the hypotenuse is 10. So again, you do not have to have these memorized, but I would try to know at least these 4 at the top, just because it will save you some time if you know them. Now, just to make sure, I would go ahead and do the Pythagorean theorem, just to make sure that you know them, but if you can memorize those, then you'll be great. Okay, so that's it. Make sure you show all of your work on your homework, and we'll go over it when I get back.